Pond Water Level Management System.
So for the introduction of our project, fish, like many living organisms, have specific tolerant range of environmental parameters. Thus, fish farming of specific type of fish species requires certain conditions that have to be reached. So people working in the fish farming ponds have to be engaged in daily activities to maintain the living fish habitat. Today, the environmental impact to the aquaculture production is very much in focus, and the demands of the industry is increasing. So most of the fish pond owners still use the old technique that is more conventional. The fish pond owner depends on the water level, whether it is high tide or low tide, to add or reduce the water. So the automatic method in controlling the water level of fish pond is much easier than the manual. So the basic operation of the sense system is to control the water level that will depend on the sensor and the input of the user. The system consists of two systems, the control panel system and the main system. So for the control panel system, it comprises of an RTC for the parent purposes and an LCD as an output for the inputted operation of the user using a keypad. A transceiver module is used to build the communication between the two systems. So monitoring and taking action to maintain the habitats of water species and to shorten the time needed for some basic action are the main purposes why the system was developed. So for the objective of the study, here are the objectives of our system. So first is to design a system that controls the water level of the fish pond automatically, and develop a system using electronic components to prevent the fish pond from draining and overflowing and help the fish pond owner to make work easier, and evaluate the project in terms of functionality, reliability, safety, and ease of use. The significance of the study. The fish pond water level management system can help both the fish pond owner and the laborer. So for the fish pond owner, the owner can easily manage his or her pond with the help of the system, because it can convert the manual procedure into an automated way of monitoring the pond. So for the fish pond laborer, they can reduce the time on checking and determining when to open the barrier or the slab in order to add or reduce the water level of the pond. For the future researcher, they can get some ideas on how monitoring of the water of the fish pond is done by the help of the modern technology. So for the scope and limitation. So the scope, designed to automatically control the fish pond barrier, which ensure the maintenance of the water level. The automatic water level management system can automatically decrease, fill, drain, or change the value depending upon the input of the user by using the control panel. So for the limitation of our project, the sudden cut-off of the electric supply is the main factor that will make it useless, and the communication loss of the two systems due to some interference. So chapter 2, the review of related literature. So for the foreign literature, here are the references. The IOP Conference Series, Material Science and Engineering, Volume 340 by Z. Harman and E. Reda, Year 2016, entitled The Real-Time Fish Pond Monitoring and Automation Using Arduino. The investment and operating costs are the biggest obstacle in modernizing fish ponds in an otherwise very lucrative industry. So for the local literature, the Philippine e-journals entitled The Water Level Indicator and Temperature Indicator by Alan B. Almaden, year 2012, stated that they construct an auto-filler tank that could be controlled by a standalone circuit that has a water level indicator. The device would automatically fill the tank when the water level was at its minimum, and would also automatically close the inlet when the water level was at its maximum. The design had an automated temperature controller that maintains the required temperature needed by the user. So for the related studies, Singh and Bansal, year 2011, entitled Monitoring Water Level in Agriculture Using Sensor Network, said that the water level monitoring system are important in the application related to the agriculture, flood prevention, and fishing industry, and has been widely used to reduce the danger of disasters and make sure the safety of ship channels and control the aquatic environment. So for the technology used in order to build the fish pond water level management system, the following technologies were used by the developer. So first is the Arduino boards. So Arduino is an open source computer hardware and software company project and user community that design and manufacture single board microcontroller and microcontroller kits for building digital devices and interactive objects that can sense and control objects in the physical and digital world. Second is the linear actuator. So it is the device that converts the rational motion of an AC or DC motor into linear motion. That is, it will provide both push and pull movements. By pushing and pulling, it is possible to lift, drop, slide, adjust, tilt, push, or pull objects simply by pushing a button. So next is the RTC or the real-time clock module. It is an IC that keeps an updated track of the current time. This information can be read by microprocessor, usually over a serial interface to facilitate the software performing the functions that are time-dependent. Next is the LCD or the liquid crystal display. So this is a flat panel display which uses liquid crystal in its primary form of operation. The LCD will use to display or to provide the user about the status of the water level in the pan. So next is the float switch or the float sensor. It is used to control a pump while filling or emptying a water tank. The switch position is adjustable along the float cord. Floating switches are simple to install and designed to control a pump to automatically fill or empty a water tank. A float switch is a type of level sensor device used to detect the level of liquid within a tank. Next is the relay module. So it classified into many types. A standard and generally used relay is made up of electromagnetic, which in general used as a switch. So next is the keypad. So a keypad is a set of buttons arranged in a block or pad which bears digits, symbol, or alphabetical letters. Pads mostly contains number called a numeric keypad. So next is the NRF24L01 transceiver module. So basically it is a wireless transceiver which is used to send and receive data by using radio waves. It is a single chip transceiver module. It uses SPI protocol for transmitting data. Its data transmission speed is up to 2 Mbps. So next is the block diagram of the fish pond water level management system. So this figure shows the process of the fish pond water level management system. So the user can select the needed command by using the keypad. The water level sensor, which is the float sensor, will provide a signal to the microcontroller in controlling the relay module and the linear actuator. The mechanism of increasing and decreasing the water of reservoir will be done via relay frames or relay module and linear actuator. The measurement will be determined if the water level changes, and the display system will be used in displaying the status of the system. Next is the conceptual paradigm of the system. So the figure shows the input that the researcher used to develop the project, such as microcontrollers, laptop, electronics component, the software, which is the Arduino IDE, and the ECEDA. So for the process, it includes the problem identification, research, requirements, specification, concept generation, design or the system flow, the prototyping and construct, the system test, the system integration and evaluation, and for the output is our project, which is the fish pond water level management system. The chapter 3, the methods and the research. So for the design, this is the design process, a descriptive overview of the system by Ralph M. Ford and Chris Fulston. For the problem identification, so problem identification provides the platform for investigating a broad range of intervention and generating options. The process of identification involves the development of clear, straightforward problem statements that can be linked directly with the specific goals and objectives. So managing the fish pond is hard for the workers as well as for the fish pond owners, especially when it comes in managing or checking the water level of the pond. So controlling manually the water level of the pond is laborious. This may result to inaccurate measurement of the water. The manual procedure also has disadvantage. It must be checked from time to time to know the current status of the pond. By having that kind of scenario, the fish pond owners, especially those who owns a wide area of pond, must hire more manpower just to check the pond. The research. So research is the collection and evaluation of information about a particular subject. The overarching purpose of research is to answer the question and generate new knowledge. It is also a systematic inquiry to describe, explain, predict, and control the observed phenomenon. So the developers gathered information about some unfamiliar components used in constructing the project. So by reading some articles and magazine, the developer gathered more information. They also asked questions to the personnel in the field of fisheries to know their current procedure and how to control the water level of the pond. So the block diagram and the circuitry of the existing project were also analyzed by the developer in order to get some ideas on how to construct the fish pond water level management system. So next is the requirement specification. So before the system is designed and implemented, the requirement has to be specified enough to detail to make analysis and design possible. This is a big part of system engineering, especially for larger systems. So the developers discuss and design the features of the fish pond water level management system. Aside from being able to perform its operation, which is to monitor the water level of the pond, the system must also be user-friendly. The system has linear actuator in both sides of the system to make the slabs move in upward or downward motion. The system will help the laborer to minimize the time they consume in monitoring the water level. Fish pond water level management system uses 220 volts, so the unit will not require frequent battery charges. So next is the concept generation. It is a procedure that begins with a set of customer needs and target specification and result in an array of product, concept design alternatives from which a final design will be selected. It requires a more abstract style of thinking that perhaps most engineering is used to. So we realized that monitoring the water level of the pond automatically does not exist at the current time, and by that reason, we visited the fish pond at our campus and we observed that the current procedure the laborer performed to monitor the water level of the pond. So next is the design. So it is defined as a framework of methods and techniques chosen by the researcher to combine various components of research in a reasonably logic manner so that the researcher's problem is efficiently handled. It provides insights about how to conduct research using a particular method. So next is the control system flowchart. So as the user turns on the system, it will display the current water level of the pond. The user can select operation. So if the user selects a command, it will send command to the main system to drain and will display draining on the LCD. So if drain is completed, it will go back to selecting operation. If B button was pressed, it will send command to the main system to fill and will display filling water on the LCD. If filling of the water is finished, it will also go back to selecting operation. So if button C is pressed, it will send command to the main system to decrease the water and will display in the LCD decreasing of water. And if decreasing the water is finished, it will go back to the select operation section. And if button D is pressed, it will show time and date and will wait for 3 seconds and will go back to the select operation section. And if 0 button is pressed, enter the number of days and time, and if it is done, it will go back to the select operation while waiting for the set date and time of changing the water. And if current time is equal to the set time, it will send command to change the water and will decrease. And if the water outside is high, it will fill the water, else it will wait. Next is the main system flowchart. So as the user turns on the system, it will wait for the command. If command is received, it will display draining, and if draining is finished, it will go back to the waiting for command section. So if command be received, it will display filling of water, and as filling of water is finished, it will also go back to the waiting for command section. And if command C is received, it will display decreasing of water, and if the decreasing is finished, it will also go back to the waiting for command section. If command C received, it will display changing of water, and if changing of water is finished, it will go back also to the waiting for command section. The layout of the system. So this is the main system box, the float sensor, the linear actuator, the slab, and the fishnet. Next is the control panel location. So this is the personnel office where the control panel will be installed. This is the control panel which comprises of the keypad, the NRF24L01, the LCD.
Next is the schematic diagram of control panel. So this diagram shows the circuit flow of the control system. The control system comprises of LCD and keypad modules, and RTC module is connected to the serial data and serial clock of the Arduino. It was used to count the number of days when changing pond water. Keypad module is connected to 8 digital pins of the microcontroller. So to send the data and receive from the control panel, it uses NRF24L01 RF module. So next is the schematic diagram of the main system. So the main system consists of 3 float switch for level detection. It is connected to the output pin of the microcontroller. So to send and receive data from the control panel, it uses NRF24L01 RF modules. The system has 2 channel relay modules connected to the output pins of the Arduino in order to control the 12 volts 5 ampere linear actuator. Next is prototype and construct. So this step includes gathering of materials, building prototype, and recording of particular details of the design that are required for replication. So these requirements such as dimension, measurements, materials, processes, and so on are described in detail. So we search for the components to use in order to build the system, and we familiarize the major components, especially the motors and the control panel section. Next is system integration. It is the process of connecting different subsystems or components into a single larger system that functions as one. It is also the process of integrating all the physical and virtual components of an organization system. During system integration, all of the subsystems were brought together to produce a complete system from researching the components and planning its features. Next is system test. So system test is testing conducted on a complete integrated system to evaluate the system compliance with its specified requirements. So the purpose of integration testing is to detect any inconsistency between the units that are integrated together. So in this phase, we have tested the system if it meets its desired output. This also shows if they meet their objectives and determine if the system can perform according to its function. Next is the evaluation. Evaluating the system includes 30 respondents, 10 respondents, students, and the remaining 20 respondents are from the community, and some are those who are under the field of the aquaculture. So the system was evaluated according to its reliability, functionality, ease of use, and safety. Reliability is the degree to which research method produces stable and consistent result. And for the functionality, it is the state in which the system has met its desired output. Its measurement of how easy the finished product is to use by its intended user. And the last is safety. It is the state of being protected from the potential harm or something that has been designed to protect or prevent harm. Chapter 4, Project Design, Testing, and Evaluation. So this chapter shows the different methods that we have done from designing the prototype and testing the output of the project, including the evaluating process, and it includes the troubleshooting process on every part of the project. Next is the evaluation of the existing project. So we realized that the proposed system did not exist at the current time, that made it difficult to visualize. So in order to gain some knowledge about the basic mechanism in the pond, especially in terms of monitoring the level of water, and studies about fish farming help us for the success of the system. Then the design consideration. So good design and user friendliness are the main consideration in developing the fish pond management system. We use stainless bar to ensure the prototype will not be rusty. So the prototype also included a frame that supports the motor to lift the metal slab, and the slab has its own fixture to guarantee the laborer that no water leakage will occur during the process. Next is the electronic assembly. So assembling of the different electronic components of the system was done in this section. So the actuator's motor were attached well on its frame together with its power. And we created a circuitry box to guarantee the components are properly installed. So this is the actual feature of the control system circuit box. So it has NRF24L01 antenna and a keypad module. It has also LCD and a switch board. turning on the control system. So as you can see, it is the inner part of the control system circuitry. So it has wires, RTC module, a power supply, NR module, and the Arduino Mega that we use to control the flow of the system. And this is the inner part of the main system circuit box. So it has a relay module. This part is the relay module and the wiring of the float sensors. And in this main system, we use Arduino Uno. So next is the mechanical assembly. So this section shows the assembly of the prototype of the fish pond water level management system, from constructing the frame of the actuators as well as the metal slab. Then we make sure that all the metals are attached well to make the system more durable and firm, especially the holder of the actuator motors. So next is the fabrication of the mechanical parts and interfacing of the electronic control. So this section shows the combination of the materials used in the system, such as the different electronic components in the mechanical elements. So the durability and the safety of the system were the main consideration of the developers, and we decided to put a frame into actuators to have the metal slab lift upward and downward motion. So this is the placement of float sensors. So the float sensor filling the water in the pan is located here, and the float sensor for decreasing the amount of the water, and last is float sensor for draining the reservoir. Next is the hardware process. So this section presents how the system operates or works and how it functions. So the fish pond water level management system uses two separated microcontrollers, one for the control panel and for the main system. So the system uses toggle switch for turning on and off the system. So whenever the main system is turned on, it will continuously wait for a command from the control panel and send the current process through the NRF modules. And the user can enter a command to the main system, and the following commands are filling, decreasing, changing, and draining the water. And every command and current process are displayed in the LCD, where displaying and setting the date and the time are also scope of the control system. So next is the commands of the system. So this is the keypad module. We use 6 buttons for the input of the control system. So A is for draining, B is for filling, C is for decreasing the water in the pan, and D is for showing the date and time for 3 seconds. Then 0 is setting the day and time for changing the water purposes. The asterisk is for setting the date and time, year, month, and day. Next is simulation, testing, and troubleshooting. So in order for the system to be successful, we simulated and tested and troubleshoot the errors happened on the system. Project testing. So the system was tested numerously to ensure that it is functional. So all of the functions of the system were tested to make it fully operational. So the summary and result of the evaluation. For the computed mean for reliability of the project, 1 out of the 30 respondents, 22 rated the project as excellent, and 8 respondents rated the reliability of the project as very good. And the calculated mean is 4.73, interpreted as excellent. For the computed mean for the functionality of the project, out of 30 respondents, 21 rated the project as excellent, and 9 respondents rated the functionality of the project as very good, and the calculated mean is 4.7, interpreted as excellent. So next is the computed mean for the ease of use of the project. So out of the 30 respondents, 19 rated the project as excellent, and 11 respondents rated as is of use of the project very good. The calculated mean is 4.7, interpreted as excellent. And lastly, the computed mean for the safety of the project. So out of the 30 respondents, 22 rated the project as excellent and 8 respondents rated the safety of the project as very good. So the calculated mean is 4.73, interpreted as excellent. So the summary and result of the evaluation. So the table shows the summary and result of the evaluation of both the student and the community. So the system was evaluated in terms of its reliability, functionality, ease of use, and safety. So the fish pond water level management system got a computed means of 4.3, which means that the system is reliable to use. And in terms of functionality, the system got computed mean of 4.7, and which means the project function based on the desired output. So based on the computed mean of the ease of use, which is 4.63, the project shows that it is user-friendly, and the fish pond water level management system is safe to use based on the computed mean, which is 4.73. And the overall weighted mean is 4.68, interpreted as excellent. Chapter 5, Summary of Findings, Conclusions, and Recommendation. This chapter presents the summary of findings, the conclusions drawn, the recommendation made on the study. The summary of findings of our project. So, fish pond water level management system designed and developed to automatically and manually operate the water system in the pond. So, below are some of the findings on the system. So, first is the project is composed of different electronic components and some mechanical parts. Next is main system has two linear actuators that consume too much current and lead into problem. Multiple steps were done in order to develop the system. And the last, after the system were completely done, the developers conducted evaluation. The conclusion of our project. Based on the result of the evaluation and summary findings, the following were drawn. So the fish pond water level management system was able to control the water level of fish pond automatically. Then the fish pond water level management system has the capability to prevent the pond from overdraining and overflowing using electronic components. So the fish pond water level management system can help both the fish pond owner and the laborer in ensuring the quality of the pond. Fish pond water level management system was evaluated as functional, reliable, user-friendly, and safe. For the recommendations, so based on the findings and conclusions presented, the following recommendations are suggested. So we recommend to use multiple channel RF module to operate numerous opening in the pond. We also recommend to use a high-speed motor to make the operation of the system faster in terms of opening and closing of the slab. So we also recommend to use a long-range transceiver for better communication. And lastly, we recommend to use a wireless communication that can operate despite of some barriers.
Before we demonstrate the functionality of this system,
We are going to show you the different parts of this project.
The parts of fish pond water level management system.
so this is the part of the system. This is the circuit box of the main system, the two linear actuators that lift the metal slab in upward and downward motion. We attach 3 water level sensor, which is the float sensor. So this float sensor is for filling purposes. This part is for decreasing purposes, and the lower part is for draining of the water.
How the system works.
So first, we need to plug in the power source of the system, the control system, and the main system.
We are going to show you how this project works. So first is turn on the system. As we turn on the system, so the level of water is displayed on the LCD, whether it is high, low, or in mid-level. So as you can see, the water level is high. So if the user want to drain the fish pond, press A to drain. If drain command selected, so the main system send the data to the control panel and it displays draining.
If the water level reaches the float sensor for draining, if the process was done, finish will be displayed on the LCD.
As you can see, the water level is low. If the user want to fill the pond, press B to fill.
If the water level reaches the float sensor for filling, if the process was done, finish will be displayed on the LCD.
So this is in high state. So if the user want to decrease the water in the fish pond, press C to decrease.
If the water level reaches the float sensor for decreasing, if the process was done, finish will be displayed on the LCD.
If the user want to know the current date and time, press D. In changing the water in the pond, the user can set his desired date and time by pressing the button 0. If the current date and time is equal to the user set time, the LCD will display a reminder.
So that's how our project works. Thank you and God bless.